Hello and welcome to part 6 of Dev Maths and Stats Refresher Course, Lecture 6. Now here we turn to some basic maths in Excel to make sure you're comfortable with entering formulas and manipulating things and using graphs to explore different kinds of function. We'll use this kind of thing a lot in the next few days, and also you'll meet it a lot during the year. So we're working with the file simplemaths.xls, which is this one. You can download from Blackboard or Teams, wherever we are today. And the first sheet in the Excel, this one, unlike the previous one, has got many worksheets. In the jargon, the file is called a workbook, and these are called worksheets. You just click from one to the other on the bottom like this. You can add more as you wish. So at the top, we've got this set up to give us some tables of different kinds of function based on this value of x in the first column. So first of all, you need to know how to use the formulas discussed previously to enter this kind of function. So here are some linear functions, here's some quadratic functions, some exponentials and some logs. There are examples of these in cells B2 to G2. So first of all, just check you know how to write all of these in normal algebraic form. So for example, I'll just write a couple of these out. So maybe this quadratic here. So in this one, if the function was y, that would be y is equal to, was it in the right order? You can't really say 85 plus 16. So a2 is referring to the x, and then plus or minus 3. a2 is x again, so x squared. So this is showing 85 plus 16x minus 3x squared. Okay. And oops. The exponential one, I think this is easier. This is just how much increments? Just e. Oops. E to the x. Okay. And this is log of 1 plus x. So let me not write that. Okay, so you should be able to write these in normal algebra, and you should be able to take anything here and put it into the Excel form. Okay, include things like this. So here you'd have to have 4x brackets, a half x to the power 2, close brackets, to give you this. So that's how you enter things in. But once you've entered in, functions 2 has got one that I made earlier. So it's got basically the same thing, but it's got actual values. So I think I've actually used exactly the same function. I'll just make it made it a bit smaller, and it's got a chart what shows what's happened. So these are the values that we had just over the page. You see actually how I started on row 4. Oops. So I think that's exactly the same values as back here. Yeah. So instead of just taking one value, now we've got values to go from 0 up to, I don't know what, up to 30, and it shows the value from 0 to 30, so that's plotted along here of all of these functions. And you can just choose which function is graphed by clicking on here. So you want to leave this on the x, just move this to the other columns and you can see the other graphs instantly drawn. And all the functions are controlled by the parameters at the top. So the first one, for example, is this linear one. This is, I've labelled them here, so A and B. So this is AX plus B. Let's have a look. Yeah, so it's A So b is the constant, and this is, so it's -4 times x plus 7. So -4 times x plus 7. So this is the coefficient of x, and this is the constant. If that makes sense. So hopefully you know what to expect. If we increase the, is that really the case? No, it's not. 7 is the coefficient of x. This is the constant. Yeah. So if we increase the 7 to 8, you see what's happened is that this has become steeper. Look at where this is coming to. It's going up nearly to 250. If we take this down, back to where it was before, 7, it goes down. If you change it to 1, then it's much flatter. But the graph is rescaling automatically, so it's hard to see. If you were to make it negative, then here you have a dramatic change, because that's coming down. And remember, the -4 is where it starts here. So while it starts from 30, and from -30 and go upwards, I could change this to -30. I could change this to 12. It got up quite steeply from -30. So you should have complete control over this one. The quadratic, if you come to here, let's just graph the quadratic. So to have a look at the quadratic, you just click on this and carefully move that across to there. So you can see the quadratic is doing something like this. In the quadratic, let's try and get this right this time. The coefficient of x squared, so that this is the coefficient of x squared, so it's ax squared plus bx plus c, as you'd expect in the formula. So this 16 is controlling where it starts, the point here. This is going to control the extent to which it dips down, more or less. So if you take -12 off there, it's going to be a bit more of a dip. And then this controls, because as x gets bigger, the only thing that really matters is x squared. So if you double that, then it's really going to put it up sharply like this. And then you'd have to make this much bigger and negative to really put it down. So that'd really give it a steep dip like that. Yeah. So that's the quadratics. You can do similar things with the cubics. Again, it's this thing that matters as it gets larger. This is the intercept. These things control really the intermediate stage. So let's just have a look at these. I mean, it's not so easy to be precise about those two numbers, but if you scale this up, you start lifting this side of the equation. If you bring this down, then you start getting more as this S-shaped graph. And then you have to pull this right up to make sure you get the classic cubic shape developing. Okay, so the smaller numbers affect the kind of behaviour of the smaller value. The smaller powers affect the smaller powers more. The smaller values more, but the behaviour at each end is dominated by the cubic one here. I'll leave you to explore the quartic. I'll just show you the basic shape of that, which I think will just come up if we move across the quartic. So again, this has got the classic W shape quartic if it goes into negative areas. So for negative x, it would go up in the same way. And then the powers. So power parameters here. Just make sure we can write down what the equation is. So what are these? For the polynomials, each power of x has got its coefficient. For the exponents, it's not quite as simple as that, because here we have, as an equation, if I use the ABCs, so y, if we call this variable y on this axis, is equal to, so f1 is just it's just multiplying the fronts. Then a7, so x, to the power of, so f2, so b is the component. Okay, so I've just done that. Okay. Yeah. So you can tell what effect these three things are having. This is just going to shunt it up and down. this will just magnify the graph up and down, and this will give you the way it slopes. So because it's a 0.5, it's got this diminishing returns thing here. So it's the square root of x at the moment. Okay, so that's a fractional power one. So you can try all sorts of things with this. Get a smaller power one. Making a smaller power, for example, so you get a sharper rise and a sharper tailing off. Exponents here. What's this function look like here? There's a whole load of parameters. So let's see if we can write out what that is. So again, if it's easy, you should be pushing down fast forward. If it's difficult, you should be pressing pause and try and write down, what am I going to write here? Y is equal to what from these coefficients? So it's going to be A as a multiplying parameter times E. There's a whole lot of stuff, so it's, yeah, so it's 2, so it's bx plus c. And then plus d. So we've got a sort of magnifying factor, a moving up and down factor, and then this will condense the graph in this kind of direction. Oh, it'll translate the graph. C will move the graph leftwards and rightwards, and B will, what's the phrase, squash it towards the origin, condense it, compress it. Okay, let's go back to the cursor. So, which one was which? That was the condensed one. This one should be a bit long. And that's the one that moves it long. Okay, the reason we're not seeing anything is that we're still graphing the power. Okay, yes, that's better. Restore what we had before. Gosh. Okay, so that's the exponent. So we can magnify it a bit, compress it back towards the left a little bit, which is one. Is that naught? And G2 is that, that's okay. Yeah. Okay, it's a very awkward scale actually. So I think you have to really, yeah, okay. So you have to really expand it out the other way, yeah, to see what's happening. Okay, so that's the exponent, so you can get back towards the more traditional look. And then finally the log, which is, as you know, is flipped up this way. So similar to the power. In fact, you can see that we're starting at, so there's a multiplying factor, and so y is equal to a log h2 is the base. So this, you might recognise this number, this is e, so in actual fact, because this is e, I'm setting it to log, a natural log, so it's actually ln, but the formula is log to any base, so you can put base 10 or anything in, and then it's cx plus d plus e. So you can experiment with the effects these have, magnifying it, shifting it along and so on. D is set to 1, so essentially whatever number we have, we're essentially starting from a log of 1, because if we set these, the reason of having d there set to 1, Okay, let's just remove the cursor. Remember, if d is 0, then you get this weird thing, and that should be that goes down to minus infinity at the point 0, that their numbers. You can't calculate minus infinity. So that's set as 1 to make sure we start from that point onwards. Okay, so there's a good exploration of that. So I hope that that was either useful, or I hope that you played with it yourself and got a feel for what shape the equations are and how you can move the graph from one to the other to investigate the shape of each graph using the same scatter graph. Okay, so next part we go on to the worksheet rearrange, and we look at rearranging equations, but I'll do that in the next video, and thanks for watching.